Hey YouTube, how's it going? Welcome back to another mini guide here. Today we're going to be going over singletons, what they are, why you use them, all that jazz. So a singleton is a design pattern in which you only ever have one instance of that class, okay? And majority of the time it resembles a static class, but the only time it resembles a static class is because the instance itself is static. So the idea is when you call the instance, it will either already have a version of it made or one will be created for you. Now, that works all fine and dandy for general C#. There are a few extra kinks, I guess, for Unity itself. And the method that I'm going to be showing you for the singleton pattern is going to look different from if you went and Google searched it, for example. So there's many varieties of the singleton pattern, and feel free to use mine. I enjoy using my take on the singleton pattern because it kind of cleans up your class, where some people just put it directly in the class and you can reuse it. So we're going to be using a generic singleton. And so right now I just have an empty scene. I just called it mini guides, and I had a camera and a directional light. I just threw it in a little container here called miscellaneous. So I'm going to create an empty game object. I'm going to call this code, and then we're going to save the scene. And I just made a folder under assets called code, and then I made a folder called utility. And inside utility, we're going to go to create, and we're going to go to C# script, and we're going to name it Singleton. Okay. Beautiful. Okay, so the singleton itself obviously doesn't really work by itself. It works in tandem with whatever system you're trying to build. So a good example of a singleton could be an audio manager, a scene loader manager, anything that you would only really have one of. And at any point in time, no matter the script, you might need access to it. So the loading scene manager is super handy because at any time you could be, hey, loader manager, I need to switch scenes, and then it could do it because you have a singleton instance and you don't need a reference to it. So the first thing we're going to do is, if your template looks a little different than mine, by the way, I just have templates set up for Unity. So I'm going to be using namespaces, and in my other tutorial series, I always go by project. I miss the code folder, and then I go by the folder that's it. So it'll be project.utility. So when you need to bring in into other classes, you're going to be using project.utility. Okay, so in order to make this a generic, we need to add the little less than greater than sign. So we're going to say, we're just going to use T here. And then we're going to make sure we want to kind of cast T in a way that when you throw in your type, your class type into singleton, it has to be of a mono behavior. So if you just make it a regular C# class, it won't really work. We wanted to make sure that it's a mono behavior. And the reason why we're doing that is because we're going to be using a function in Unity called don't destroy on load, which requires it to be a mono behavior. Okay, so we don't need any start or update functions. We're actually going to create a public virtual void awake. So Unity has all the functions for like start, awake, update, and all them, and you can have different versions of them. They can be public, they can be private, whatever. We're going to make the function here virtual so that our class, our loader scene, our audio manager, whatever needs to be a singleton, can also use the awake function. So they could use the awake, and then they could call base.awake. We're going to have the awake function, and so we're going to make the instance. So the instance is what you're going to be calling. So if you're calling this from another class, which I'll be showing you, you'll say audio manager.instance. Okay, and instance is always a type of T, right? So it's going to be generic, like I'm saying. We're going to pass in T here. So in our case, it could be audio manager, and then this would be of type audio manager. And it's just going to be a nice little C# property. We're going to have a get with a private set. So the private set means that it has to be created within the start here. Oh, my bad. we're going to do private set. I don't know why I was typing all this stuff. Okay, cool. So in the awake here, we're just going to check to see if the instance is null. So the idea is that when this starts up, if you had multiple versions of this in your scene, it would only ever create one. So we're going to check if the instance is null, it means we never created one. Or sorry, if the instance is not null, it means we have more than one. So we're just going to destroy this one, right? So I'll show you an example here in a minute, and then we'll just return, because you don't need to do anything else. And I'll show you in a minute, if you had two of them, it'll get rid of the second one. Okay, cool. So if it's not null, it's going to destroy and return, and then basically it'd never get down here. We're going to say instance, and then we're going to say this as t. And it's actually instance equals this of t. So we're going to set instance to this class, and we're going to cast it as t. So you could do it this as t, and this should work as well. Not in this case. Okay, not with generics. So this as t. Sometimes the casting works that way as well. Okay, so now we're going to be using Unity's special don't destroy on load. So what this does is that if you were to change scenes, like hard change scenes, this class would never get destroyed. And you'll see when you start your scene, it'll put it in like this little extra category called, I believe it's don't destroy on load. And then we're just going to throw that class. So the idea here is we're going to have an instance for the class. And then on awake, we're going to check if it's not null. If it's not null, it means we have more than one. We're going to destroy it and just return. If it is null, we're going to create a new version of it. And then we're going to set this guy to don't destroy. Okay, cool. So, like I said before, we really can't attach this to here. So I'm going to create a new folder called managers. So typically these fall under managers, and one of the goals in line is, while the singleton pattern is super handy, you don't want to overuse it. And so make sure that when you are designing that this thing never gets destroyed. So if you had like a single level and you were like, oh, I'm going to have this level manager and it's going to be a singleton, so any object in my level can access it. Well, when you go to change out the level, that level manager is still there. So yeah, make sure that for the singleton pattern, the good use case is that it typically is always there throughout the lifetime cycle of the application, or in this case, the game. Okay, so we're gonna call this test manager, and then we're gonna open this. Okay, so we have test manager, and I'm just gonna put this as .managers. .manager. There we go. Okay, so the first thing we're gonna do is we're gonna bring in the namespace. So we're gonna say using project.utility. Okay, right? So this using statement matches the namespace provided for Singleton. And then we're going to inherit from it. So we're going to say test manager is going to no longer be a mono behavior, it's going to be a singleton. And then we're going to pass in test manager. Beautiful. So this is still a mono behavior, right? Because singleton inherits from mono behavior, right? So we're just saying that the singleton is of the type test manager, and then we can still attach it to a game object because it's a mono behavior. Cool. So I'll just show you a quick little thing. So if you do need access to the awake function, you can do public void awake, and then you can say base.awake. And it's going to give you a little heck here saying that, oh, you know what, you're overriding because it's set to virtual, so you're going to want to make sure that you set public override on the awake. You don't need to do it for starter update. We only, in this case, use awake, so that is good. So this, if you weren't to call this, it wouldn't set up the singleton, and then things would get all messy. So if you do need access to on awake, make sure you set it up this way. In this case, we don't really need to. Okay, so we're just gonna start. We're gonna say debug.log singleton ready. And while we're here, we're gonna end up making a test script. So we're just gonna have a public void test function. Okay, and this will just show you that you can kind of call it wherever you want. So with the static class, normally this would be static, and you wouldn't be able to have, you would have always like static variables and stuff, and then if you'd get a change of everything being static if this had to be a static function. But with the singleton pattern, everything is just like a normal class. So it's just like hello world test function. Okay. All right. So we save that. We're gonna go back to our scene here, and we're gonna open up the code object. Make sure everything compiles. Make sure you check your bottom right here. Make sure the little spinny thing stops spinning. If it's still spinning, your class won't show up here. So we're gonna attach the test manager. And one of the things to keep aware is when you use the don't destroy unload, it brings the whole game object and all its children to it over to don't destroy. So if you attach regular game objects onto here, they're going to get brought over as don't destroy as well. They won't be instants like singletons, but they won't get destroyed. So make sure like you either have all singletons or that sort of stuff when you're making a game. Okay, so we're going to attach it to code, and we're going to hit play. And you'll notice we have singleton ready. And like I said before, it kind of creates this like extra scene and throws the whole game object there. So if I had just like a standard class that I made, it would get brought over as well. Okay, so I'm going to create another object. We're just going to call this my player, my test player. And the idea behind this is that this is going to be a simple class that interacts with it. Okay, so I'm going to make a new folder called gameplay here. And inside there, I'm going to make a script, and we're going to call this test player. And we're going to go ahead and open that. We're going to call this project.gameplay. Okay, so on its update, we are going to just set up a simple if input dot get key down keyboard dot q, and basically we're just going to check to see if you have the q key, and if you have the q key, then we're going to go and we're going to look for our singleton. So our test manager is in the namespace project manager. So you can either type it in here and bring it up, or you could go using project.manager. And then you can go to test manager.instance. And then we're going to make a new test function. Okay, so now we've made our input with Q. Just going to fire the test function here. It should say hello world for us. So we're going to go over to my test player. Do that. We're going to attach test player to them. We're going to save the scene, and we're going to hit play. And you'll see singleton ready. And if I hit into the game and I hit Q, we got hello world till our heart pleases. And we have no really reference of that class, just the fact that it has a static version of instance where we can access all its stuff. Okay, so let's show the bread and butter of the singleton pattern, which is multiple test managers. So if I copy this a couple times and then I hit play, you'll notice that in this case, so what in this case, it makes one don't destroy code for test manager, and in here it does some cleanup where it removes the script for all the other ones. So the reason why I don't delete the game object is because sometimes you do have multiple other stuff on it, and if you deleted that whole game object, it would get rid of stuff. If you wanted to do that, you could still delete the whole game object. My Singleton instance just deletes the script itself, so you're left with just a bunch of empty game objects, which I think is a pretty good compromise to go over anyways. So that's the Singleton pattern, its use case, and how it works. I hope you guys enjoyed this mini tutorial, and as always, have a good one. Just wanted to make sure I give a nice shout out to the people over on Patreon that help me support and help me do Twitch and YouTube tutorials. So thank you, and you guys will be in the following list. Jaron Frost. Hey everyone, if you guys liked the video, make sure you guys click that subscribe button, give it a like, and make sure to comment. It really helps out. And if you guys are looking to support the project further, I also have my Patreon, which will be linked in the description down below. Thank you, and have a good day.